Have you ever just stopped and looked around at the world? I mean, your phone, your laptop, even your washing machine and microwave. They're all kind of smart, right? They all have this little bit of intelligence baked right into them. But where does that actually come from?
So let's really get into that with one big question. What is that tiny, almost secret engine that powers basically everything? We're talking traffic lights, medical equipment, all of it. It is the true unsung hero of our digital age. Well, the answer is the microprocessor. Now, I know that sounds a bit technical, but trust me, this tiny little chip is the main character in our story today. It's the hidden force that makes our modern world, well, work.
Okay, so what is it exactly? To put it simply, a microprocessor is the entire brain of a computer. Its central processing unit, or CPU, but it's been shrunk down and crammed onto a single tiny piece of silicon. Seriously, if you take this chip out, a computer is just an empty, useless box. To really appreciate just how amazing this little thing is, we've got to go back in time. Back to an era when computers were anything but tiny. This was, without a doubt, the age of computer giants. So, way back in the 1940s, the very first computers were these massive, room-sized beasts, buzzing with thousands of vacuum tubes and just chugging an insane amount of power. The second generation brought us transistors, which made computers smaller and faster. Then, the third generation gave us integrated circuits, shrinking them down even more. But the real revolution? That was still coming.
And that brings us to the fourth generation, the one that changed everything. This was the moment that engineers pulled off what seemed impossible, putting an entire computer brain onto one single chip.
The year was 1971, and in so many ways, this is the moment that really set the stage for the world we live in right now. A small team of engineers figured out how to cram all the essential parts of a CPU onto one tiny little sliver of silicon.
And this is so important. This wasn't just another small engineering step. It was a giant leap. This single invention is what kicked off the personal computer era. All of a sudden, the idea of a computer sitting on your own desk in your own home, that went from pure science fiction to a very real possibility.
And here it is, the Intel 4004, the world's very first commercially available microprocessor. It was a humble 4-bit chip. And get this for a fun fact. The company name, Intel, is just a mashup of the words integrated and electronics. Pretty clever, huh?
You see, the invention of the 4004 didn't just open the door, it blew the floodgates wide open. What came next was an absolute explosion in computing power, with new, much more powerful microprocessors being developed at a dizzying speed.
And what's really wild is just how quickly things escalated. In 1971, you have the 4-bit 4004. Just 5 years later, Intel drops the 8-bit 8085. And then, only 2 years after that, the 16-bit 8086 arrives. So what does bit size even mean? Think of it this way. A 4-bit chip can handle simple numbers. A 16-bit chip can process entire words and much more complex instructions all at once. This explosive growth just kept going, leading us to the 32-bit and 64-bit processors that we all consider standard today.
All right, so let's fast forward. How did that historical power surge lead to the world we see all around us? The answer is microprocessors are now completely and invisibly woven into the fabric of our daily lives.
I mean, yeah, obviously they're in our computers and our phones, but think bigger. They're running our appliances. They're managing traffic control systems to keep us all safe. They're powering critical medical equipment that saves lives. And they're the literal brains inside modern robotics and automation. Pretty much any electronic device you can think of has one of these inside it.
But hey, they aren't magic. Microprocessors have huge advantages. They're incredibly fast, they're low cost, they're tiny, and they're super reliable. On the other hand, they can't work alone. They need external hardware like memory and other devices to function. A single chip also has pretty limited abilities, and you need to know how to program them to make them do anything useful.
Which brings us right to today. We've gone on this incredible journey from massive vacuum tubes to tiny transistors to integrated circuits and finally to the microprocessor. Now, the 5th generation is dawning and it seems to be all about artificial intelligence. So the real question becomes, what's the next great leap for these tiny, powerful brains that run our world? What will they learn to do next?